Howdy! Welcome to Aspire Mountain Academy. I'm Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video provides practice learning the requirements for the binomial distribution. Let's get started. So what we're going to do here is look at a number of examples in which we're going to be asking the question, could we model the situation with the binomial probability distribution? In order to assess that, we have to go through each of the requirements for the binomial distribution to see that those requirements are met. If all those requirements are met, then yes, we can model the situation with the binomial distribution. If not, then not. All right, let's get started. So our first example here is surveying 150 random adults about their favorite ice cream flavor. Could we model this situation with the binomial probability distribution? Well, do you remember what the requirements are for the binomial distribution? The first requirement is that the procedure has a fixed number of trials. Do we have a fixed number of trials here? What say you? Yes, we do have a fixed number of trials. There are 150 adults. So every time we ask one of those adults, we're I guess what you could call executing a trial. And so, there's an outcome from that trial. Okay, they respond with their favorite flavor of ice cream. But there's a fixed number of trials, 150 subjects. The second requirement is that the trials must be independent. So what say you? Are these trials independent? Generally speaking, yes, each trial is going to be independent. I mean, if you're with a group of people and you're asked the question, you might give a response, that's influenced by your desire to appear a certain way amongst the people that are around you. But generally speaking, people's favorite ice cream flavor is not going to be dependent on what other people think. It's going to be dependent on what they like. And so, yes, we're going to say each of these trials is independent. The third requirement is that each trial must have one of only two outcomes. So what say you? Do we have this requirement met here? Okay, here we have each trial having more than just two outcomes. There are many, many possible outcomes here because there are many, many different flavors of ice cream. And each flavor of ice cream has its fan club. So we have more than two outcomes that are possible for each of the trials, and so this requirement is not met. The last requirement is that the probability of a success must remain the same in all the trials. Do we have this requirement met? Well, I hope you said yes, we do. The probability of success remains constant, okay? However it is that we're defining success. So, whether or not, say success is having chocolate as your favorite ice cream flavor. Well, there's a certain probability associated with that, and it's going to be the same. The probability of someone answering chocolate for their favorite flavor is going to be the same, no matter how many people you ask. So it's going to be the constant throughout each of the trials. So we've got 3 out of 4, which, in most cases is not pretty bad, but this is one of those cases where doesn't quite pull through. So because all of the requirements are not met, then we would say no, modeling with the binomial distribution is not appropriate for this situation. And that's how we run through this. So let's run through another example. Now we're surveying 150 random adults about whether they like dip waffle cones. So again, let's go through our requirements. First is the procedure has a fixed number of trials. What say you? Do we have this requirement met? The answer is yes, we do. There's 150 subjects for the survey, so the number of trials is fixed. The trials must be independent. Do we have this requirement met? Well, each trial is independent. Again, what you like or don't like depends entirely upon you. Third requirement, each trial must have one of only two outcomes. Do we have this requirement met? And yes, we do have this requirement met. There's only two possible outcomes to this question. Either you like dip waffle cones or you don't like dip waffle cones. It's one or the other. There's no in between here. No fence setting allowed. And finally, the probability of a success remains the same in all trials. Do we have this requirement met? Yes, we do have this requirement met. The probability of success is constant. Therefore, because we've got all of the requirements met, we can say yes, modeling with the binomial probability distribution is appropriate. Let's look at another situation involving marbles in a bag. So we've got 3 marbles drawn from a bag without replacement, and the ones that are green are noted. So what say you? Go ahead and stop the video here. See if you can remember the requirements for the binomial distribution, and then evaluate whether each of those is met. Come back and we'll see how you did. Well, here we've got the first requirement. The procedure has a fixed number of trials. And yes, there are 3 marbles drawn from the bag. That's a fixed number. Next, the trials must be independent. And yes, we have dependent trials here because the trials are conducted without replacement. That makes them dependent events. So no, this requirement is not met. The third requirement, each trial must have one of only 2 outcomes. And yeah, there's many outcomes here because, for all we know, there's a ton of different colors in the bag. So we are noting the green ones, but how many other colors are there? There's plenty of possibilities. And we aren't told what's in the bag, so we have to assume, it could be anything. And finally, the probability of a success remains the same in all trials. And the probability of success is actually changing with each marble drawn because it's without replacement. So here we see that we've only got one of the 4 actually met. Because all 4 are not met, we would say no, modeling with the binomial distribution is not appropriate. Let's look at one more example. This one involving giving an experimental drug to 85 patients to find the number of favorable responses. Go ahead, stop the video, then we'll come back and see how you did with answering the question, could you model the following situation with the binomial distribution? Okay, let's see how you did here. So first up, procedure has a fixed number of trials. Yes, we have a fixed number of trials. There's 85 subjects. The trials must be independent. And yes, each trial here is independent. What we, giving the drug to one patient's not, determined or dependent upon what we give to another patient. The favorable responses we get, those aren't dependent. Each trial must have one of only 2 outcomes. And yep, there's only 2 possible outcomes. Either the drug works or it doesn't. No in between here. And finally, the probability of a success remains the same in all trials. And yes, we see the probability of success is constant for each patient. So here we've got all 4 met. Therefore, we would say yes, modeling with the binomial probability distribution is appropriate. And that brings us to the end of this mini lecture. I hope you found it helpful. You can find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching. I'll see you in the next video.